Hello class, welcome back. Today we're going to go ahead and get started on section 6.2. All right, on section 6.2. And this section it's going to use everything we've used in this last week. All right, so in the previous section we found out how to find the z-values, right? How to find the probability or the area under the normal distribution curve, right? As long as we're giving a specific value, right, which we associated with x, a mean, right, which we associated with mu, and with sigma, right, which we associate with standard deviation. All right, so the formula we've been using is z is equal to x minus mu over sigma, right? And this is what this entire section is going to be a continuation of that, but with real world life applications, right? With word problems. But it's going to be the same idea. It's going to be the exact same thing, right? Where you're gonna have to locate these values, and of course, right, if you do not have it already, please be sure that you have your important formula sheets, right, and the tables printed out, specifically table E, all right, the standard normal distribution, or right, some of you may refer to it as the Z table, right? So make sure you have that handy because we're going to be using that. All right, so let's go ahead and continue. All right, so we have a word problem here. A worker in the auto industry works an average of so many hours, right, per week. If the distribution is approximately normal with a standard deviation of 1.4 hours, what is the probability? Okay, so right then and there, right? What is the probability that a randomly selected automobile worker works less than 41 hours per week, right? So right, one of the main things you need to look out for is it what's mentioned: at most, at least, work less, work more, right? That's going to determine which probability values do you find after you find your z-score. All right, so once you find z, all right, do you want everything in the right to the left, or do you want everything to the right? Right, so it's all going to determine on that. And based on this one, right, this says works less than 51 hours per week. I know I'm going to look at everything to the left, right? I'll go ahead and make a little notation, right? I'll go ahead and make a left. So let's the main thing you want to go ahead and do with these is write down exactly what was given to you. All right, it works as an average. So my mean, right, is 42.9. A standard deviation, all right, this gives me 1.4, and my x value, right, my focus value is 41. All right, it's gonna go ahead and be in 41. All right, so let's go ahead and find the probability for the x value that's less than 41. All right, so let's go ahead and plug what we know in. All right, so this is 41 minus 42.9 all over 1.4. Right, and when we go ahead and plug that in, let's see what this gives us. All right, I end up in the decimal, right? Two decimal places, right? So I would state this is negative 1.36. Right, so my z equals negative 1.36, but I don't want to stop here. All right, I need to go ahead and give the probability, right? And I won't be pulling up this table the entire time. All right, at a point, I'm going to just go ahead and be reading it out from the one I have printed out. Just make sure you're following along, all right, with your sheet as well. And we said, what was my probability? It was negative 1.36. All right, so we said we're going to look for negative 1.3. Negative 1.3, which is right here. And I need to cross that with 0.6, right, which is here. Meaning that my value, the probability at that point is 0.0869. 0.0869, or, right, you multiply this by 100, and this gives me 8.69%. All right. And this is to the left, right? So we said that whenever you're reading these, it's going to give you always, right, regardless of where you are in the table, it's always going to give you everything less than that, right? It's always going to give you anything less than that. And you need to be careful if you're asked to find something greater than something, right? You will still locate that z value, but you're going to do 1 minus the probability that you found, right? If you're still unsure or unclear about that process, I would highly recommend you go ahead and review from section 6.1, right? Because all those methods, right? Greater than, less than, bounded between, working backwards, right? Given the probability and then finding the x value, we're going to be using all those examples here, right? So let's go ahead and. Right, so the probability that we got was negative 1.36. I'm sorry, guys, I lost it. It should be 0.0869, right? Right, very nice. So let's go ahead and move on to example 2, right? And it's only going to be a few of these. I'm only going to be doing a few of these because, like I said, the main thing comes down to identifying, right? It comes down to identifying the values that you're given, and then it's the same thing. So I'm only going to do a few of them just as a refresher. All right. So let's go ahead and move on to section 1.2, to problem 1.2. And the example 2 states SAT scores, right? The national average SAT score for a verbal and math is 1028, right? So let's go ahead and write that out. So this is my average that's given to me. Assuming a normal distribution of sigma equals 92, round the intermediate z value corresponding to 2 decimal places, right? To 2 decimal places. Right, so in other words here, right, in other words, for this problem, I need to go ahead and find for part A, all right, what is the 72nd percentile score, all right? So here, right, they're giving me my percentage, right? This is a 72nd percentile, which is just 72%, right? And if it's a percentile, I want everything less than 72, right? So everything less than 72. And this as a decimal, right? 72 divided by 100, 0.72. Right, so this is the probability. So now what I need to go ahead and do is find the z value that corresponds to 72%, right? Right, so we would go ahead and look at our z-score, and 72 is greater than 50%, right? So I know this has to be on the right-hand side, right? Because the halfway point is 0.50 or 50%, meaning 72 or 0.72 has to be on the right. So we said we work backwards by finding 72 in here, right? Right here. I can use this one, or I can use the one on the right. And we said the key here was to find out which one is closer to 72, right? Which is closer to 7200, right? 0.7200. Is it the one on the left or the one on the right? And we know it's the one on the left because the one on the left is only 10 points away from 72, and then one on the right is 24 points away. All right. So this means I'm going to use 0.58 as my z value. (0.58), meaning that if I were, right, we know our formula, I'm going to go ahead and plug in what I know. So this is 0.58 equals x minus 8 over 92. Right, and all we're doing here is solving for x. So, right, I don't want any denominators, so I'm going to go ahead and multiply both sides by 92. These cancel out, which was my goal. Then I'm left with 0.58 times 92. And this here gives me 53.36, right? 53.36. Right. Meaning I'm going to go ahead and put 8. And last but not least, right, I want to go ahead and solve for that. All right. So this here is going to give me, add this to both sides. There we go. Right. So meaning 1028 plus that value, right? This here ends up giving me 1081.36 is equal to x, or right, rounding it up to my closest value, right? This here would give me, right, you can leave it like this, 10x is equal to 1081.36, or rounding it off to your nearest whole number, right? This would be 1081, all right? So that'll be the x value, right? The test score that corresponds to the 72nd percentile, right? So I'm asked here, what is the probability that a random selected score exceeds 147? All right. Exceeds 147. So this is an exceed problem, meaning, let me go ahead and delete this, meaning what they're giving me here now is an 1147. That's my x value, all right? So I'm going to have to go ahead and find the probability for that, all right? All right, so here I have z is equal to x minus mu over sigma, which is 1147 minus 1028 over 92, which is equal to 1147 minus 1028 divided by 92. I get 1.2 decimals, right? 1.29, right? 1.29. So where's my formula sheet? There we go. I'm going to go to 1.29, right? 1.29, which is here, right? 1.2, right? So that's 0.9015. Right, but it's 0.9015 for everything less than that, right? I don't want less than that. The problem here exceeds, right? It has to be greater, all right? So in other words, this is going to be 1 minus 0.9015, right? 1 minus 0.9015. This here ends up giving me a 0.0985. In other words, this is a 9.85%. Very nice, right? Very, very nice. Okay, let's go ahead and move on to example number 3. Right, so example number 3, right, the average commute to work one way is 25 minutes. All right, so that's average, all right, average. So that's going to be my mean, right, my average, my mu, which is 25 minutes. According to the 2005 American Community Survey, if we assume that the commuting times are normally distributed in a standard dev of 6.1, right, calculate the probability that a randomly selected commuter speeds for the following cases. Round the final answer to at least 4 decimal places, and intermediate z-value calculations to 2 decimal places. All right, so the first one is more than 35, right? So hey, all right, I already know this, right? What they're asking me here to get. Let's go ahead and, all right, that's going to be my x value, right? Is more than 35, more than 35. Oh, you can just say this and then find p of x greater than 35, right? Meaning e is equal to x minus mu over sigma, right, which is 35 minus 25 over 1. Right. And this is going to give me what? 10 over 6.1, which is, right, and it said, I'm going to go ahead and do everything up to 4. 1.6393. All right. And since my z values, right, I'm only allowed to find up to 2 decimal places, right? Meaning this is going to be 1.64. All right, so that's the z value I'm looking for. Z equals 1.64. So z equals 1.64, 1.6. All right, so this gives me 0.9495. Right, but don't forget, this is more than 35, right? So in other words, I want everything to the right of that z-score, right? Of that z-value. I want to the right of all that, right? Meaning that I'm going to do 1 minus that p-value, right? Which is 1 minus 0.9495, meaning the probability of more than 35 minutes commuting one way, right? 1 minus 0.9495 is 0.0505, right? Very, very nice. Or in other words, 5.05%. And then you would go ahead and do the same thing, right? So you're asking again a different question, but less than 9 minutes computing one way, right? Commuting one way, meaning, right, that you would do this all over again, but your x value is going to be 9, right? Meaning you're going to look for x less than 9, right? So that's how you would go ahead and approach those. Okay, let's go ahead and get started and continue. Go ahead and continue on example number 4. All right, and cat behavior. Yeah, cats are nice, right? All right, so a report stated the average number of times a cat returns to his food bowl during the day is 36, right? And that, right, the word there was kind of lost in the very beginning. This is average, right? Average. 36, assuming that the variable is normally distributed, my standard deviation is 5. What is the probability that a cat will return to its dish between 32 and 38 times a day? Ooh, wow. Okay, right. So now we have a boundary type of problem, all right, where we have to locate between there and there, all right? And we mentioned before that you would have to do this twice, right? We would call this is probability 1, and we would call this z probability 2, right? And that we would find them, right? Because z1 is going to spit out probability 1, right? When you find it on the table, z2 is going to spit out probability 2. And what we want to do here is the largest one minus the smallest one, or in other words, the one to the farthest right minus the one to the left. All right, so this is pretty much what we're going to do here, right? Let's work this one out together. All right, so my z1 to the left, right, is equal to x1 minus the mu over the standard deviation, right? And the next one is going to be z2 minus is equal to x2 minus mu over standard deviation, where my x1, right, let me go ahead and label this here. My x1 is going to be 32, and my x2 is going to be 38, all right? So let's go ahead and find z1s, right? z1 is equal to 32 minus 36 all over 5, meaning I end up getting negative 0.80. Right, let's go ahead and find z2. This gives me 38 minus 36 all over, what's that, 5. That's 3 over 5, or 2 over 5, sorry. Meaning this is 0.40. Right, so let's go ahead and find the probability values for those, right? Let's start with negative 0.80. Negative 0.80, right? 8.8, that belongs to 0 or to 1? 0, right? 0, 0, that's the one we're looking for. So this is 0.2119. Right, and now let's find it for 0.40. And I know I said I wasn't gonna pull it up, but it's handy already, right? The sheet, so why not? 0.40, it's right here, all right? 0.4, right? That's the one I'm looking for. 0.6554, 0.6554. Right, and I'm gonna go ahead and do the largest minus the smallest. And right, if you're not sure which one you end up doing, you don't know the difference that you got, we know it always has to be positive, right? We mentioned that probability always has to be positive. So so this is going to be T2 minus P1. It's equal to 0.6554 minus 0.2119. Let's see what that gives us. 0.6554 minus 0.219. This here ends up giving me 0.4435, or it's supposed to be or 44.35%. There's your answer. Right. Let's go ahead and jump into continue to example number 5. Okay, so this problem is this problem states new home prices. If the average price of a new one-family home is $246,300, right? Average. So I know this is for this house problem. This average is $246,300 with a standard dev of 15,000. Find the minimum and maximum values of the house. Ooh, okay. That a contractor will build to satisfy the middle 82% of the market, right? And you see how these problems are getting more and more applicable, right, to real world life scenarios. This is the wonderful thing about this class, right? Of the market, assume that the variable is normally distributed around round your z-value calculations to 2 decimal places and your final answers to the nearest dollar, right? So you just need to remember that at the very end, it's going to be to the nearest dollar, and everywhere along the way, there's going to be 2 decimal places. Right. So, it's raining. So, right. So what do we find here? Right. The key word here is to satisfy the middle 82%. Right. And remember that table that I had brought up, right? This one here, right? Well, I had mentioned between the mean, right? Between the mean and a standard deviation to the right and standard deviation to the left, that accounts for 68.3% of your probability, right? In other words, if 68.3 engulfs the whole thing, then approximately each side is going to have 34.15 and the other side 34.15, right? Right, we went ahead and mentioned this a few sections back, right? So we're going to go ahead and use that idea. All right, we're going to go ahead and use that idea going in. So in other words, I'm looking for 82% of the entire middle part. All right. One thing I know, all right, is the 50% mark is in the middle. All right. So we know that going in. So if it's 82 engulfing the entire piece, let me go ahead and draw this a little bit better. Right, if 82 is from, let's just say, from here to here, right, how much is each half? Right, and what do you do there, right? You divide it by 2, all right? So in other words, this here is going to belong to 41%, and this here is 41%. All right, so let's focus on the right side, right? Let's go ahead and focus on the right side. If I know that my middle point is 50%, right? At 50%, right? And if I go over by 41, right? In other words, if I'm dealing with decimals, I can go ahead and find that value, all right? Go ahead and find that value, right? Meaning that this is approximately 50% plus 41%, right? Or in other words, this is 0.50 plus 0.41 if I'm dealing with decimals, all right? If I'm dealing with decimals, right? Meaning the probability value that I'm looking for is 0.91, all right? So in other words, the probability value that I'm looking for is here, and I'm gonna find out what Z value belongs to that, right? So let me go ahead and save this one, right? I'm gonna go ahead and save this one. I'll go ahead and call this, let's call it P2, right? Probability 2, the one on the far right, right? And then I want to go ahead and find the distance between 50, but going back this way, right? So instead of adding 41%, or instead of adding 41% to the 50, I'm going to subtract, right? Because I want to go back the other way. So in other words, this is going to be 50% minus 41%, which is 0.50 minus 0.41, which is going to be what? All right. Nine, right? So these are the values that I'm looking for. These are the values that I'm looking for. Right, so now what I'm going to go ahead and do is find the Z values that correlate to that, right? Let's go ahead and find the Z value that corresponds to that. So 0.09, I'm going to look for that in the middle, 0.09, 0.09. Make sure I wrote that right. 0.09, yes. This is about, this is pretty close right there. Right. This is one tick away. So that is negative 1.34. Right. Let me go ahead and find 0.91 now, right? And that's greater, that's right. So it's going to be on the right side of this table. 0.91 for this one, right? That is, again, one tick away, right? So this is positive 1.34. Right, and you would assume that, right? Because we're dealing with a symmetrical curve, right? And this is evenly in half, right? This is 82%, right? It only makes sense that these two values here will be the same and just differ by the negative value, right? So now what I need to go ahead and do, right, well, what are we finding? All right, what are we finding? What we need to find here is my X value, all right? So in other words, what I'm finding here is for my X value. Meaning, right, and how do I know that? Because they wanted me to find the minimum and maximum prices of the house that a contractor would buy, all right? All right, so meaning, all right, let's find Z1. Z1 equals X1 minus mu over standard dev. So in other words, this is negative 1.34 is equal to X1 minus, what was my mean, right? 246,300 all over 15, right? And again, right, I don't want that denominator, so I'm going to multiply both sides by 1,500. Times 1,500 is negative 10 is equal to X1 minus 246,300, meaning X1 is equal to 244,290, right? I would then go ahead and do the same thing, right? But for Z2, right? For my far value. Meaning this ends up giving me meaning this here ends up giving me, actually that'll still be 2010, right? That'll still be 2010, but positive 2010 x2 so that's 2010 plus 246, 300, meaning my x2 is 248, 310. Right, so these are the prices, right? We knew that this was the lowest bound, so this has to be my lowest value, and this is my highest bound, right? This has to be my largest value. Very nice. Okay, let's go ahead and move on to the last problem, which is going to be problem number 6, example number 6. High school competency test, a mandatory comp test for high school sophomores, had a normal distribution with a mean of 460 and a standard deviation of 91. Round the final answers to the nearest whole number and intermediate, or along the way, to 2 decimal places. So here, let's go ahead and see what's given to me. All right. I'm told here that the top 3% of students received $500. What is the minimum score you will need to receive this award? All right. So we need to go ahead and be careful here, right? Because everything else is not in monetary values, right? If you notice from the previous problems, whether I was looking for my standard deviation or for my mean, it was in the same units here, all right? Unlike this one, the units are not the same, right? So this is just an award. This is just a qualification, like a score, all right? So in other words, I'm going to be focused on the top 3%, all right? I'm going to be focused on the top 3%. So right here. And where does that happen? That happens at the 97% mark, right? If you go from here to here, right, that's going to go ahead and give you the 97% mark, all right? So what I need to go ahead and do is find that. Well, what is that, all right? And in case you're wondering, hey, how else can I find that? Well, it's going to be 100% minus that value, all right, to get that probability, which gives me 97%, which is just 0.97, right, 0.9700. So what we're going to go ahead and do now is find that z value, all right? So my probability is that I need to find the z value that corresponds to that, right? To 0.9700. I would say this one. This one is pretty close, right? So it's off by a tick. So I would say this is 1.88, right? 1.88. That is going to be 1.88. Right, at this point, I'm going to go ahead and find, right, that minimum score. So in other words, I have z is equal to x minus or standard dev, which is 1.88 x, right? Because I'm looking for I want to know what x is at that exact point, at that 0.9700 mark. What was it doing? Oh, my mean 460 over 91, right? I'll let you go ahead and solve that, right? And what we should get, right, what I end up getting as a whole number would be 631, right? That is my x value, right? Meaning that is the lowest score you would have to get so you can receive the $500, all right? It has to be a pretty high score, all right? It has to be a pretty high score, right? And it's going to be higher than normal because my average, right, is just 460, right? My average score is just 460. All right, so that's a pretty high score, all right? You would, if that's at least what you need, that's a really high score, all right? So, and you're also told, all right, that the bottom 1.5% of students must go to summer school. What is the minimum score you will need to stay out of this group? All right. right? So this probability is going to change, right? So now we're dealing with another scenario. Now I'm dealing with the low 1.5%, all right, with the low 1.5%. All right, so in other words, I don't have to do 100 minus anything because I'm not looking for the top end, right? So that's just 1.5. My probability is just 1. Sorry, my probability is just 1.5%, which in decimal is right 1.5 divided by 100. This here should give me 0.015, right? 4 units. So I can pull this up on my table. So now on my table, it looks like 6. I'm going to go ahead and look for 0.015. And that has to be in the lower end, 0.015, 0.015. Whoa. Right here, right? 0.0150, exactly. So I would say this is negative 2.17. Right, negative 2.17. Right, so I'm going to go ahead and find out what score do you need, right? What is the highest to not go to summer school, or in other words, what is the lowest you would have to not go to summer school, right? Right, that value out there would make a difference whether you go to summer school or not. All right, so again, right, we're going to use the same formula. Z minus Z is equal to X F. This is negative 2.17 is equal to X minus 460 over 91, right? Right, and right, I'll go ahead and let you figure that out computationally, and your X value should be all right, I got here 262.53. Let's go ahead and round up to play it safe, right? Because you don't want to round low, because what if you get something in between there, right? You're still going to get out. So I would say, hey, play it safe. Just make sure that your score is above this, right? If your score is above this, hey, guess what? On the comp test, all right? Hey, guess what? You're good, all right? You don't have to worry about summer school. But this is all for today. Oh yeah, and a hint, right? I want to go ahead and give a hint, a hint for the last problem, right? So you're going to be giving an array, right? You're going to be giving set of data, right? And I believe I put the option to be around 15 points, right? So you're going to get values, right? Like 30, right? Like on test 1, 30, 33, 68, 50, and so forth, right? You're going to, and I put this question as a refresher because it all comes back, right? It all comes back. You're going to have to find, right? You're going to be given this array of values. You're going to have to construct a histogram. Right? You have to construct a histogram, and tell me about the distribution, right? Tell me about the distribution of the curve. All right, is it negatively skewed, positively skewed? All right. Another thing you're going to go ahead and ask to find will be the Pearson's index of skewness, right? Where this index we said was 3 times the mean, right? Minus the median all over the standard deviation, all right? The standard deviation. All right, so that's a hint, all right? That's going to be a hint. You're also going to have, asked to locate Q1 for that data, Q3 for that data, and IQR. But for this one, I'm not asking you to find any outliers, right? No outliers. This one time though, right? This one time. No outliers. All right, so we need to remember how to do that because you may see that on exam 2 again. All right, and yeah. All right, so this is as a hint, right? In case, hey, is he asking us again? Yeah, because it all comes back. Right, it all comes back. So that is all I have for you today. Thank you very much for your time and happy studying. Thank you very much.